Hello and welcome to myfinanceteacher.org. In this video, let's talk about basics of bond valuation. And before we jump into the valuation formulas, let's have a look at some basic features of bonds. Bond, as you know, is simply a debt contract or a debt security, which represents an IOU basically. And corporations issue bonds to raise capital, to obtain capital from investors who would like to lend that capital to the corporations. If those investors would like to lend to the corporation rather than participate in the ownership of the company, then they might purchase the company's bonds rather than its shares. Bonds have a face value, or another name for that is a par value. That's basically, as the name suggests, the amount that is written on the face of the bond. That's if the bonds were in the form of paper as they used to be decades ago. Nowadays, of course, everything is more digital. And this face value, face amount, or par value is paid to the investor, to the holder of the bond, at the bond's maturity, or at the time when the bond expires. Coupon rate is the rate as a percentage of the face value that the bond pays regularly to the investors. But of course, there is a particular type of bonds, the so-called discount bonds, which don't pay any coupon, which don't pay any interest to the holder of the bond during the bond's life. They only pay a face value, which is of course supposed to be larger than the price paid for those bonds. But in case if the bonds do pay some interest, if the bonds do pay some coupon, those usually are equal to the interest rate on the bond, the yield to maturity on the bond, the market rate on the bond at the time of its issue, and to find the actual coupon payment, the regular amount that the bond pays, we simply multiply the coupon rate by the face value. Maturity, as I've already mentioned, is the time when the bond expires. That's the time when the face value is paid to the investors. And the yield to maturity is simply another name for the return, for the interest rate that you can earn on the bonds if you hold that bond until maturity. That rate is also used to discount the future cash flows that the bond promises in the form of coupon payments and the face value. So that yield to maturity, the discount rate, the market rate is used in bond valuation as well. And as there are many different kinds of rates, many different forms of interest rates, to avoid any confusion, any interest rates, including yield to maturity, are quoted on the APR basis, annual percentage rate. Next, let's have a look at the timeline of the bond to see its visual representation. Here it is. We have a bond that matures in 4 years. These numbers 0, 1, 2, 3, 4. Let's say they represent the number of years on this timeline. And this sort of representation on the timeline is very important for our understanding of what's actually going on with the cash flows promised by the bond. If you understand what's generally going on, all the other calculations are going to be relatively easy. The computer is going to help you with any of the calculations that you might have to do. So I want to highlight this understanding here. This perhaps is the most important concept you want to understand about bonds. So there are some promised future cash flows in the form of coupon payments and the face value. As you see, coupon payments are these regular payments which are paid every year in this particular example. Sometimes they're paid more frequently. And the face value is the amount paid at the maturity of the bond. And of course, the actual coupon that is paid every year, so let's say the annual coupon, is equal to the product of coupon rate and the face value. But notice that coupon rate is frequently not the same as the ongoing market interest rate that we use to calculate bond valuation, which is of course PV, present value, or the price, as if you were to buy the bond now, you would presently pay its price. So you have these future cash flows promised by the bond. If you want to calculate its worth right now, its price right now, you would discount all of those future cash flows using the ongoing market interest rate. And as I mentioned, coupon payments are sometimes made more frequently than once a year. Here's another example with semi-annual coupon payments, where the coupon is paid twice per year. Sometimes it could be even more frequently than that. But again, in this example, the annual coupon is the product of the coupon rate by the face value. Remember, because the rates are expressed in the form of APR, or the annual percentage rate. If instead you want to calculate the actual payment every time, every half a year, the semi-annual payment, then we need to divide that annual coupon, the product of coupon rate and face value, by 2, by the number of these coupon payments per year, as there could be more frequent payments as well. And finally, with this general understanding of what's going on with the bond, what does the bond promise, and how do we discount those future cash flows to find its worth, its value today, we can jump into the formula for this valuation, which consists of calculating the value of this annuity. Remember, annuity is a payment of a regular amount over regular periods, that's the coupon payments, and a lump sum payment of the face value at the end of the bond's life. And I don't know how about you, I find this formula quite big and cumbersome, maybe even a little bit intimidating. So what I want to point out here is that in the 21st century, we're going to use computers, we're going to use Excel in this particular video to calculate all sorts of things related to bond valuation. So we don't need to be intimidated by this sort of formulas. So let's jump into Excel for some examples. Let's say you are just about to buy a bond that matures in 5 years with a face value of $2,000. Let's say the coupon rate on the bond is 4.2%, but the ongoing interest rate on the market is 5.8%. The coupon payment is, let's say, annual. The question is, how much are you willing to pay for the bond? This sort of question, of course, implies calculating the present value of the bond, or the price of the bond. Actually, usually it's only one of these 5 variables that you have to calculate in relation to a bond valuation. It's either present value, or PV, future value, FV, rate, or the yield to maturity, NPR, or the number of periods, or the PMT, which is the regular payment of the coupon in this example. Usually it's a good idea to figure out which 4 of these 5 variables are given, leaving us to calculate the 5th one. In this example, the face value is 2,000, the yield to maturity, or the rate, is 5.8%, number of periods is 5 years, and the regular coupon payment is equal to the coupon rate, 4.8%, multiplied by the face value of 2,000. And to calculate the present value, the price of the bond, just hit equals, type PV, open the brackets, and the computer will give you all the hints for what you need to enter, starting with the rate, hit comma, number of periods, another comma, the regular payment, comma again, and the face value. Close the brackets, hit enter, make sure you have enough space in the cell to see the numbers, giving us the present value of negative $1,915.29. That's negative because if you're buying the bond right now, it's going to be a cash outflow out of your pocket, and the future payments promised by the bond are going to be cash inflows back into your pocket. Let's have a look at another example over here, very similar, with the only difference being the interest rate. Let's increase it from 5.8% to 8.8%. Let's see what we can learn about the relationship between interest rate and the price of the bond. Let me copy all these numbers and change the market rate to 8.8%. Again, to find the price equals PV, open the brackets, enter the rate, the number of periods, the regular payments, and the face value, giving us a smaller price of under $1,700. So the first thing we are learning from a couple of these examples is that the relationship between the price of the bond and the interest rate is the inverse one, because we are discounting the future cash flows promised by the bond using this interest rate, using this yield to maturity. The larger the discount rate, the larger the interest rate, the larger is the yield to maturity, the lower is the bond price implied. And let's see what we can learn from another couple of similar examples. Let me just copy the data here and only change the time to maturity, making the bonds of a longer term. Let's turn both of these 2 new bonds into 12-year bonds. making this couple of bonds on the left a bit of a shorter term 5-year bonds, and these couple of bonds on the right a bit of a longer term 12-year bonds. And what we're going to notice here is that while the difference in prices between the two shorter term bonds is much less than $300, the difference in prices between the two longer term bonds is actually more than $400. It's also larger in percentage terms, this difference as well. So we are learning from this example of 4 bonds that while the relationship between price of the bond and interest rate is a negative one, meaning that as interest rates rise, the price drops and vice versa, this sensitivity of price to interest rates is greater for longer term bonds. We see that for the same change in interest rates from 5.8% to 8.8%, the price of a longer term bonds falls by more, both in the actual numbers as well as the percentage terms. Now let's have a look at one last example with the more frequent coupon payments. Let's say you are buying a 6-year bond with a face value of 10,000, coupon rate is 3.6%, but the payments are made semi-annually, that's twice per annum. Market interest rate is 5.6%. Say we need to calculate how much is the price of the bond, meaning that we need to find PV. Everything else is given to us with a face value of 10,000. In this case, we need to be accurate as the computer doesn't know whether we are facing a problem with annual, semi-annual or other kind of payments. So the rate that we apply, we should divide that from the APR, annual percentage rate, down into the appropriate intervals given in the problem. In this case, we divide that by 2. So 5.6% divided by 2 is our rate. Number of periods, rather than number of years, we have a 6-year bond with semi-annual payments, semi-annual periods. That's going to give us 12 periods in this bond, 12 regular payments of the semi-annual coupon. And that regular payment, the PMT, is going to be that annual coupon, which is the product of coupon rate and face value, divided by the number of periods in a year, in this case 2. So $180 is paid every half a year. Again, to calculate the price in this case, hit equals PV, open the brackets, rate, comma number of periods, comma PMT, comma face value. Close the bracket, hit enter, and we get a price of just under $9,000. I hope this video on bond valuation is helpful. If it is, I would appreciate it if you hit that like button. And of course, if you have any questions, I welcome them down in the comments below. For any upcoming tests, share this video with your friends and good luck with your exams.